Hi, Dr. Ward here. In our previous videos, we've looked at some of the fundamental concepts of dimensional analysis, as well as what I call simple one- or two-step dimensional analysis problems. There are going to be times, though, when we need more than two steps, and there are also going to be some situations where we need to convert units that appear on both the top and the bottom, so typical kind of derived units, things like density, speed, things like that. So let's take a look at a multi-step dimensional analysis problem. The biggest difference between this and what we've done before is we're going to need more conversion factors. So let's take a look at a problem like 2.5 years equals how many seconds? Well, obviously you could look this up on the internet. And maybe you know how many seconds there are in a year. That's something that you could learn by memorization. But we're going to solve it using dimensional analysis. And we don't have a direct conversion from years to seconds. I don't know of one intermediate step that would get me from years to seconds, like days, for example. I don't know how many seconds there are in a day. I don't know how many, or weeks and things like that. But since we do have 2 units of time, we can start by thinking about what units do we have and can we get from years to seconds by taking more than 1 or 2 steps. So let's think about, we know that 1 year equals 365 days. We know that 1 day equals 24 hours. 1 hour equals 60 minutes. 1 minute equals 60 seconds. Okay, so now we've got a path from years to days to hours to minutes to seconds. So we can get from years to seconds, just not in 1 or even 2 steps. By the way, we could have done this the other way around. I could have started with seconds and built my way up if I was more comfortable with that. So now let's set this up as a dimensional analysis problem. We're going to start with our given, which was 2.5 years. And somewhere over here, we're going to end up with some number of seconds. So our first conversion is to convert years into days. And since I have years that I'm given, and I want to cancel that out, I need to put years in the denominator. Again, if it helps, you can put 2.5 over 1 to keep your numerator and denominator straight. So let's set this up as a dimensional analysis problem, starting with 2.5 years. And we're going to end up over here with some number of seconds. In between, we're going to use all these conversions that we have set up to calculate the number of seconds in 2.5 years. So our first conversion is going to be years to days. And since I have years given, I want years in my denominator to cancel out. So I'm going to have 1 year. And on the top will be 365 days. Again, if it helps to keep your numerator and denominator organized, you can put 2.5 years over 1. It's the same thing. So now I've converted years to days, and then I want to go days to hours. Remember, since I want to cancel here, I want to put days on the bottom. 1 day is 24 hours. Hours into minutes. Hours on the top, hours have to be on the bottom. And that's 60 minutes. And then finally 1 minute, put minute in the denominator, and 60 seconds on the top. So now, one thing that may be helpful, and it's not going to be perfectly clean here, but there's another way to set these up that might be helpful if you're struggling with the numerator and denominator. And if you're unsure about any of these concepts and you haven't watched the earlier videos, you could go back and watch some of the simpler setups. And how and why we use these numerators and denominators and how all that works conceptually. But you can set this up, sort of called the railroad track method, separate these out, and that might help you track numerator, denominator. Also, sometimes people struggle with which things do I multiply and then which things do I divide. So this helps keep track of all these things on the top get multiplied together. All these things on the bottom get multiplied together, and at the end, you divide the numerator and denominator to get your final answer. Since all of my denominators are 1, I'm not going to need to divide by that. But now I'm going to just double check my conversion factors. I've got years and years, days and days, hours and hours, minutes and minutes. Seconds is the thing that doesn't cancel out, and that's what I wanted my answer to be. So that shows me that I probably set this up correctly. And from here, it's a matter of doing the math. So I multiply 2.5 times 365 times 24 times 60 times 60. All of that is going to be over 1. So the end result is just what I get when I multiply all of my numerators together, which is 78,840,000. Okay, so 78,840,000 seconds equals 2.5 years. Okay, so we didn't know directly how many seconds there were, but by breaking this down into smaller increments and using multiple conversion factors, we can get from one unit to the other by finding the things that they have in common, even if it takes a couple of steps to get there. Next, we'll take a look at what do we do if we have a unit that appears in the numerator and a different unit in the denominator, and we have to convert both of them simultaneously. So let's take a look at that. So what if we have units in the numerator and the denominator and we have to convert them both in the same problem? Let's take a look at an example like convert 55 miles per hour to meters per second. Okay? So we have to convert miles to meters and we have to convert hours to seconds. So this is going to be an example of a multi-step problem like we saw in the last example, and we're also going to have to keep track of units in the numerator and denominator to get them both converted so that we have a different unit in our answer from what we started with, but again it'll be the same value expressed in different units. So first we need to know our conversion factors. So 1 mile equals 1.61 kilometers. 1 kilometer equals 1,000 meters. Okay, so there's our conversions to get miles to meters. We also need to convert hours to seconds. So we're going to need a couple of steps there. 1 hour equals 60 minutes. And 1 minute equals 60 seconds. So we're going to convert both of these units at the same time in the same problem. Now we could do these separately and kind of put them together at the end, but I'm going to show you how to do this all as one problem set up together. The most important thing is going to be keeping track of your cancellation, which is important in all the dimensional analysis, but especially here where we're used to, in all the problems we've seen so far, just focusing on a unit that's in the numerator. Now we have one in the denominator, which just means a little more to keep track of. So let's take a look. And remember that 55 miles per hour could be rewritten as 55 miles per 1 hour. We did this before where we just put 1 in the denominator, keep track of our numerator and denominator, but now we actually have a unit there, so it's 55 miles for every 1 hour. That's what 55 miles per hour means. And we're going to have an end result over here in meters per second. Okay, so let's go back and first look at converting our numerator unit. So this is going to be just like what we've done so far. Okay, we have miles, and we need to convert that. So miles to kilometers, remember we need miles in our numerator. Kilometer is 1.61, so 1.61 kilometers is 1 mile. And then we're going to convert kilometers into meters, and then we'll be done with our numerator conversion. Then we'll go back and look at our denominator conversion. So 1 kilometer is 1,000 meters. Okay, so in these two steps, we're converting miles to meters. In the next couple of steps, we're going to convert hours to seconds, and then we're going to do all the calculations together. So again, I could have just done this, gotten this answer, and it would have had meters per hour, and then I can convert hours to seconds. But let's do it all at once. Okay, so now, here's the big difference with this type of problem. I've got hours in the denominator, so I need to put the conversion with hours in the numerator to cancel it out this way instead of this way. Okay, so we're going from 1 hour to 60 minutes, and then 1 minute to 60 seconds. Okay, so here's where this comes through. So let's take a look at our units canceling. I'm canceling miles and miles and kilometers and kilometers. I'm not canceling out meters, so I'm going to end with meters over here, which is what I want. Hours on the denominator cancels down here to hours in the numerator, then minutes to minutes. So I have seconds in the denominator, which is what I want. And if I do all of this, what I end up with is 88,500 meters over 3,600 seconds. And then when I convert that down, or simplify that, it comes out to 24.58 meters per second. There's some more that comes after that. But going back to our significant figures, we started with 55 miles. All the others are conversion factors which don't go into the rounding equation, the rounding consideration. So 2 significant figures, so I'm going to round this to 25 meters per second. 25 meters per second is equal to 55 miles per hour. So it's a multi-step problem with units in the numerator and denominator that have to be converted at the same time. And so we'll take another look at some examples like this in the last video, which will just be several example problems with different types of dimensional analysis. In the next video, we're going to look at how we handle things like squared and cubed units when we're doing dimensional analysis.